Okay, so we had the question in class about if you, well, okay, so the question on the homework was p is less than 0.05, and you're doing a two-tailed p-value with alpha two two-tail. Man, that's a big fat thing I'm writing with. Alpha two-tail equals 0.05, right? And so the question was, this is what we wanted to know. Do we have to split this? Is marking that it's a two-tailed test telling us that really what we need to do is think about it as 0.025? That was the question. And so would this be significant or not? Well, here's the answer. We went back and talked about this a little bit, and we thought this is actually kind of a as you guys noticed in class, it says less than 0.05. So just treat it as less than 0.05. This will be significant. If you come up to a question like this, p is less than 0.05, it doesn't really matter what it says here for the tail. It'll be significant if it says less than 0.05. So what I want to do really quickly, because I think most of you followed along with that debate of why that would make sense, and why it wouldn't, to use 0.05 or 0.025. But just in case you followed it while we were in class, and then as soon as you got out of class, it was like, now wait a second, that doesn't make any sense anymore. That's okay. We'll go through it really quickly. So basically, you have your distribution here. That's a little bit better. If we're going to do a one-tail, let's say that we're going to set our alpha to 0.05. And it's just a one-tail. Sorry for all this clicking. That's going to be annoying on the recording. So we're just going to do one-tailed test. Oh, you know what? It's way cooler to do it like this. So here's the rejection region. Yeah, this is way better. Here's the rejection region. Okay, right there. So this is 0.05. That's pretty straightforward, right? You're doing this when you have a directional hypothesis. We know that for sure. You guys remember that, so this is going to be directional. Instead of saying that A is different than B, you would say A is greater than B. And so that's where you get this. Okay, everybody knows that. We're all fine on this. Problem comes in when we switch to two-tailed, right? So let's look at that now. If we're going to do two-tail, we come over here and we're going to make a tail here and we're going to make a tail here. Now the problem with this is our alpha is still 0.05, which means that that's from, a whole, the whole probability, which would be 1. Probability of 1 is everything in the study. So we know that 1 minus our alpha, which is 1 minus 0.05, is everything not beyond the rejection region, right? So everything right here, this is 0.95. That has to stay the same with one tail and two tail. It's got to be 0.95 inside. So if you move to a two-tailed probability and you left it as 0.05 over here and you put it as 0.05 over here, all of a sudden, that means that in here it's 0.90. So That's not good. By doing two tails, you've actually raised the probability of detecting an effect that's not there. You've raised the probability of a type 1 error. We don't want that. So what we have to do instead is we split the 0.05 into 2. So in reality, on the right, it's 0.025, and on the left, it's 0.025. So now, if you add those together, it's still 0.05, and it's still 95% that is not beyond the rejection regions. So we're good. Okay, so now we have 0.25. We've split the p-value in half. Okay, cool. Now we have another issue that comes up, though. I'm going to do this one in a different color just to try to keep things kind of, I don't know, more. Let's do it in Galaxy. That seems fun. So when you're using something like Excel or SPSS, I think I spelled Excel wrong. Whatever. Yeah, should have a C. Okay. So Excel, SPSS, any of these other things, it's going to give you, it's going to give you a p-value, and you're looking for less than 0.05, no matter what. One-tailed, two-tailed, whatever. It's always less than 0.05. Now, if you're actually looking at your probabilities, we know that it's over here, it's 0.025. So if you had something where A was greater than B, let's say this is the mean for B, A, whatever quantity this is all the way over here, you know that you're comparing it to 0.025 because you're over here on the right. So if you had A be right here, and it was 0.03, you would accept the null hypothesis because it's not less than 0.025. But the problem when we're using Excel and SPSS is they don't want people to have to think about using different p-values. They want people to think about using the same p-value, 0.05, all the time, no matter what. It's easier, it's a good rule of thumb. So what they do is they multiply the p-value by 2, and that's your two-tailed p-value. That's why you see a different p-value for one-tailed and two-tailed. It's really the same p-value. The only reason why they're multiplying it by 2 is so that you can directly compare it to this rejection region here or this rejection region here and understand, oh, it's less than 0.05 or it's greater than 0.05. So that's why we have slightly different p-values. That's why we have to specify whether it's a one or two-tailed test, anything like that. Now, how does this math relate to you and your exams? Well, I looked through the exam. I tweaked one question just a little bit. You're not going to have to make this exact distinction on the exam. You're not going to be given a p of 0.03. And you're not going to have to say, is this significant or not, given a two-tailed test? Because it doesn't, it's hard to distinguish if we're asking you like the theory, like do we really want to teach you the theory? We're not training you to be statisticians, right? Like it's unlikely that any of you are going to become me. So and you could. I'm not saying that because you couldn't. I'm saying that because that's not what you're here for. You're going to school for medical studies. So this is not you don't get as excited about dumb statistical things as I do, which is, again, totally fine. If you were being trained to be a much more of a stats person, we probably would make this distinction. We'd have quite a few test questions making this distinction really clear, but again, we're not. So here's what I'm telling you. The answer is, if you see less than 0.05, it's significant if your alpha is 0.05. If your p-value is less than your alpha, it's significant. Don't worry about whether it says one-tailed or two-tailed. That's kind of there just to show that it is a one-tailed or a two-tailed test. You will have questions about, is this a one-tailed or two-tailed test? Focus on the directionality. You'll have questions about, is this p-value significant? Just compare it to whatever the alpha is. 0.05, 0.01, 0.1, 0.001, whatever it is. Just compare it to that. Don't worry about splitting it in half because it's a two-tailed. In the real world, when you're dealing with Excel, when you're dealing with SPSS, that's not something you're going to have to worry about, so don't worry about it on this exam. But this is the math and the reasoning behind why you would have a different p-value for a one versus two-tailed test. So anyway, hopefully that was informative. Hopefully that helps you study, etc. And then also, maybe I taught you that you can do weird stuff like this in PowerPoint. This is just in PowerPoint. Isn't that crazy? It's just in Draw. You just go to Draw and then you do this. It's so cool. Anyway, hopefully that helps. If you have questions, absolutely email. It's nothing that's coming up in this homework, so if you don't want to email, if you want to talk about it in person, you can ask the question while we're all there. Maybe somebody else in class has a similar question to you, so your question may help other people who don't want to ask the question. Okay, I will see you next week. Have a good weekend.